Hey, welcome to this Science Masterclass. Today we're going to do part 2 on our episode of light and lenses. Today we're looking at lenses and also looking at color. So there's two main types of lenses. One is concave, the other is convex. A lens is a transparent piece of glass or plastic that's shaped to curve outwards or inwards. They refract light and are used in many optical devices. Focal length refers to the distance from the center of the lens to the point at which light rays meet. That's called the focal point. A lens that bulges outwards is called a convex lens. These cause rays of light to converge or come together to a focal point. We can see that in the illustrations down below, where we've got light rays passing through a lens. They converge or come together to form a focal point on the other side of the lens. We can measure the focal distance by measuring the distance between that point where they come together or converge, the focal point, and the center of the lens. A concave lens is a lens that curves inwards. These cause light rays to diverge or spread out as it passes through the lens. You can see that in the illustration here on the right, where you've got a convex lens and a concave lens. You can see that with a convex lens, the rays of light come together or converge on the other side of the lens, whereas a concave lens, we measure the focal point on the inside or the side which we are passing the light through. Okay, we'll talk more about that in a minute. White light is made up of a spectrum or a range of different colors. These are red, blue, yellow, green, indigo, and violet. When they come together, they form what we call white light. Okay, this spectrum can be seen when light passes through a prism, and these colors are dispersed or split up. This is an illustration of that on the right hand side here. So when we pass a white light or normal light through a prism, each of those individual frequencies of light is bent or refracted in a slightly different amount. And that's how we can see that rainbow sort of effect or appearance come from the other side where that light is split apart. Okay, here's our visible spectrum. So the colors that we can see with our eyes, we can see red, orange, yellow, green, blue, and violet. Okay. Each color of light has a different wavelength and frequency, like sound waves have different wavelengths and frequencies, so does light. An object's color is determined by which color it reflects and absorbs. This is a really important point to understand. The color you see is the one that the object reflects. So if we look at this example of the red apple, the apple is red because it absorbs every other light but reflects red. Okay, so red apple reflects red towards our eyes but absorbs orange, yellow, blue, indigo, and violet. So every other color it absorbs except red. That's why we see it as red. Okay, so if you think about any other object that you see, say it's a green table, the color that it absorbs is every other color except green. It reflects green. That's why we see it as green. Okay, black and white colors. The color white reflects most of the light that hits it. If an object is white, it also reflects most of the radiant heat that hits it as well. So when we talked about heat energy, we also talked about how different colors can absorb and reflect light. Okay, so a black colored car reflects very little light or radiant heat energy, causing it to heat up more rapidly than the white car. Okay, so what colors are absorbed and reflected here? I'll leave that one to you. I'll give you a bit of a hint with the flower on the top left there. That one absorbs every other color except for yellow and reflects the yellow back. So that's what we see. Trick one there for the white and the black animals down the bottom. I'll let you figure that one out. Okay, primary colors. White light can be made using all colors of the spectrum, but also just by the colors red, green, and blue. These are known as primary colors. If you combine the light of primary colors in pairs, the three secondary colors are magenta, cyan, and yellow. That's what's produced. So additive colors are the blue, red, and green, and subtractive colors are the yellow, cyan, and magenta. Okay, so the primary and the secondary colors there. You can see that on the right-hand side there in that in Figure 1. Okay, so a color filter allows light of a particular color to be transmitted. Color filters are used in photography and in theaters to provide a range of light effects. They can also be used to create 3D effects. All right. Hey, that takes us to the end of this episode on light and color. Make sure you go back and watch it again. It's heaps of really important points there to remember. Make sure you subscribe to my channel, like it, and make sure you add some comments if there's something you didn't quite understand. Hey, thanks for watching.